In this chapter we're gonna finish the grain setup, so let's go. Okay, so now let's copy what we have done here and let's say everything. So I would like to see first the stick to pose, but I don't have any stage or position animated outside, so let's do it here. I just need this one to be animated with an attribute copy here from this one. So first let's see if it works. I would like the P and no. So let's try with the cust ID2 and I guess it works. Yes. That's good. Then I want the cust stage and the V. So yes, it's there. So now I can connect. Oh, I would have to fix this one. And I will. So let's set the stick to pose there. So I want the first. I'm going to use the cust stage, the position mixed from my current with the velocity from the first. And that's good. A value that I liked for the grain was 4. Okay. So let's delete this one and set those one there. I'm going to add those later. Okay, so I think it's time to do a flipbook, sorry. And let's say all except the ground plane. Actually, I'm just going to see the second one. Okay, so this is what we have. And this is correct, so let's change a couple of parameters. So I'm okay with that. Let's copy paste it there as well. I want to keep the wind. I would like to have the same on this one as well, but maybe with an offset, let's say 50. On this one I will just change a bit there the value. And I want to copy it as well there. That's you. I'm just going to redo the pop grain here. And let's say friction with particles 0 and internal collision 0 as well. And for the explicit constraint 1 here and 100,000 there. Okay. And I'm just going to tweak a bit the attribute broken. So for now, let's say I would like to compute, if we go there, let's say a new attribute, and let's isolate just one cluster. So I need to create, let's say here, an attribute that I will call i@order, not like this, equal at ptinum. Okay, and if I go back here, I will say if i@custStage is superior than i@order, then it has to break. But I don't have the custStage on my particles. I'm just getting it from there. So actually I'm going to update with another attribute wrangler. Let's copy paste this one and say update data. I want to get the i@custStage equal point from the input 0. I want the custStage with the ptinum. And I need to set this one to the first context. So now that I have that, I can set here not an import but a bind. And I'm just going to copy paste it. Let's int to float. Let's check if I wrote it correctly. Yes, I guess. So let's take out this one and this one. And I want to check another flipbook. So let's hit camera and see what we have there. So this is what we have. And I would like to change a couple of things actually. For example, I feel that it is dissolving too fast for me. So I will fix that. And I would like as well to decrease maybe the Y speed. So let's do that. And let's go there to the stick pose. So there actually. And I want to get the vector component from this one. I want the Y axis. I would like to set it back to set vector component and the Y axis as well. And I would like to multiply this one by 0.6, but only so I compare when this one is negative, because I guess the speed on the Y axis come from the bonds. So let's add a two-way switch there, compare. So if it's the case, then I want this one, otherwise I want this one, and I want to set back this to the V. Okay, and let's set it there. And maybe as well a bit of randomness might be a good idea. So let's use a random from the ID. I want to fit the data from, let's say, 0,1 to 0,35 to 1. And let's multiply this. Okay. And I would like here to add a speed ratio for the dissolving effect. So I need to compute here as well another attribute, and let's call it pity count. Actually, I do have one. So let's check. I have 17 points there. Is it working? 17. So it should be alright. So let's use an attribute promote there, and let's save so the pity count from the primitive to the detail. I want the maximum, so it's 700, and if I want the minimum, it's 11. Okay, so let's actually set it like this, there and there. I just would like to create an attribute to say if the cluster is big, then I want to make it dissolve faster than if it's small, to have overall the same dissolving time, let's say. So let's add f at speed ratio equal, so actually I need to import, so let's say int count max and int count min. Okay, I want the detail. So the max is the second input of the pity count with the index 0, and let's copy paste this one and add a semicolon here with an equal and the 1 and a semicolon. And let's say that I want to fit the I at pity count. So I need to promote it as well from the primitive to the point, but I want to make it average. So now it's there, and let's say I want float from the count min and count max there to, and let's create some parameter, chf min speed and chf max speed, like this. So let's get the parameter and say 0,1 and 2.5 for now. And let's go back here to apply it. So I don't know if I have the speed ratio there. Let's see on this one, the geometry there. Let's hide everything except the speed ratio there. This is there. So this is the maximum and this is the minimum. This is what I wanted. Okay, so let's go to my broken attribute. And I would like to say, first of all, I want to make it live longer. So let's say 6 frames. And I want to multiply this value by my speed ratio. With I need the parentheses, and I think it should be all right. Okay, so let's go back to the viewport, and there. And I would like as well to copy what I've done here. I will do something a bit different for the scale, so I will do it later. But for the normal. So if the cut stage is different than 0, then I recompute the normal. So this is what I want. And let's check the result. So this is what we have. And I think it's quite okay. I really like that kind of behavior here. Here, for example. That's very nice. And I'm going to add the collision. So let's do it. Again, I'm just going to copy paste what I've done here. Actually, it was this one anyway. Let's copy paste it there. And there as well. But because I've already tried, I know the collision by the position for the grain is a bit too much aggressive. And sometimes I have like stretchy polygons and I don't want that. So I'm going to use another way. So let's delete it and just copy paste from this one. I would like to use the collision by val with the inherit velocity. So this one. Not this one, there. And I need to set it here. And let's copy paste this one. And let's check as well the input. This is correct. This is correct. 0.15, it should be all right. Yes. So this is good. And I would like to check everything together. So this is the result. And as you can see, we have a couple of different programs from the normal, from some stretchy polygons there. There are a couple of things that I don't like as well, but it's getting there. So let's finish it.